I want to put everything back here, d sigma into, so this is one integral. I can write, let me write them two separately. So d sigma and x mu dot delta x mu over the time boundaries, and this is minus of minus t is here and d sigma is also there, and now this is integral, so I must insert here or here d tau. Okay, this was missing. Minus integral of differential of first into integral of second. Okay, and this is with respect to tau. So this d tau comes here. Let me, so this d tau I write here, and x mu double dot into delta x mu. Okay. Now this I could further write as minus t. If I combine, then this is again d2 sigma, d sigma d tau. This is okay. All right. So it is this, or now I just want to retain this term and I want to get back to I2, or I could discuss this term right away here, that this is to be done. Let me already consider this term here. Okay, so this is then this is equal to t d sigma, and this is x mu dot delta x mu, and here tau equals to plus infinity, tau equals to minus infinity. Okay, it's a definite integral. Okay, so I'm making use of this here, the boundary terms over the time, over tau, and we remember that delta x mu is 0 at tau equal to plus minus infinity both. At the infinite time boundaries, this will go to 0. So what happens is that this term contributes 0, and I am left with only one term, minus t, or let me write it plus t d2 sigma into minus del tau square x mu del tau. So this is my net result for the first integral I1. And now we want to consider the second term I2. So let me record that this is my I1, which was equal to plus t d2 sigma x mu dot delta x mu dot, correct, and this I have equals to T d2 sigma into minus del tau square x mu delta x mu. Now I can remove this and we could then proceed with the evaluation of the second integral, which is I1 plus I2. So I2 H T minus d2 sigma into minus x prime mu into delta x prime mu, and this I could write as T d2 sigma into minus x prime mu. Now this I could write as delta del sigma x mu. Okay, right? And now these two operations are again infinitesimal operations. I can interchange their locations, okay, as an approximation. Okay, so then I have this equals to T. This also I could maybe I could write it as d tau d sigma into minus x prime mu del sigma of delta x, right? And now I would first like to, because here I have a partial derivative with the space sigma, I would like to take this integral. First I would like to evaluate d sigma, integral over d sigma, and again I would like to make use of the integration by parts, and which means I consider one of them as first function and one of them as second, and integral of first function into second is first into integral of second minus integral of differential of first into integral of second. And I'm going to do it with respect to d sigma and d sigma. Okay, d tau I leave untouched. Okay, I'm not integrating over tau anymore. First time I did it with tau, now I do it with d sigma. So here I get t d tau and everything goes in here. So first function, let me take this also involve minus here. First function into, or if you like I could keep it out. Let me keep it out. Okay, let me keep this minus here out. Okay, so now first function into integral of second, we are doing it with respect to sigma del sigma of delta x mu, first into integral of second minus integral of differential of first, which means another prime, okay, minus x double prime minus integral differential of first into integral of second. So this del sigma delta x mu, okay. And now you realize that this object is simply equal to delta x mu and this object is simply equal to delta x mu, and I can put them back here. So this is minus t d tau, and this is x prime mu delta x mu, but here now I have boundary terms again, okay, but integration is with respect to sigma, so sigma boundary terms. Earlier we had the tau boundary terms, and minus integral. So let me break it up into two parts. So this is d tau, the first one, and so minus plus, minus and minus plus t d tau was already there, and d sigma comes here, and this is x double prime mu delta x. Okay, all right. Okay, so we collect them, and but this one I could also write as the first term. Let me write it as it is, plus t d2 sigma. This I can write as del sigma square x mu, and of course delta x.